All right, Unit 2, assignment number 7. These are your notes. So this is on page, in your notes packet, this is on page 21. We're going to go over what is called the triangle similarity conditions. And basically, what the triangle similarity conditions are telling us is that there are 3 different ways, rules is what we call them, that 2 triangles can be shown as similar to each other. The triangle similarity conditions. That's telling us that there are 3 different ways, which we call rules, that 2 triangles can be shown as similar to each other. The first rule is the AA rule. So we call this the AA similar rule. Remember that symbol, that squiggle symbol means similar. That's the symbol mathematicians use for when shapes are similar to one another. Okay? So, we have a red triangle. The bottom of the red triangle is 65, the bottom left angle of the red triangle is 65 degrees. The top of the red triangle is 75 degrees. Then we have a blue triangle, which is obviously a scaled down version of the red triangle. So in other words, it's a reduction. The blue triangle is a reduction of the red triangle. In the blue triangle, the top angle is 65 degrees, and the bottom right angle is 75 degrees. The vertices of the blue triangle are represented by the letters X, Y, Z. The vertices of the red triangle are represented by the letters A, B, C. And these 2 triangles would be similar to one another. Okay? So the AA similarity rule says, it says that 2 triangles will be similar if 2 angles of one triangle are equal to 2 angles of another triangle. So you can see each triangle has a 65-degree angle. Each triangle has a 75-degree angle. So by the AA rule, these 2 triangles would be similar. So we can say that triangle ABC is similar with or similar to triangle, and then we have to match up the letters in the appropriate corresponding order. So A matches up with X, B, because it's blank, matches up with Z, and C, which is 75, matches up with Y, which is also 75. So we could say that triangle ABC is similar with triangle XYZ by the angle similar rule. What is that angle similar rule say? It says that if two angles in one triangle are the same as 2 angles in another triangle, then the 2 triangles have to be similar to one another. Okay, let's go to side rule. So side rule, we call this the side similar rule or similarity rule. It's one of my similarity conditions. So in the side rule, it is talking about that there has to be some truth about the 3 sides of 2 triangles. So here we go again. We have 2 triangles, a red one and a blue one, And once again, in this example, the blue triangle is a reduction of the red triangle. Okay? The red triangle is represented by the letters D, the corner, the vertices D, E, and F. And the blue triangle's vertices are represented by the letters P, Q, and R. The shortest side of the red triangle has a length of 10. The longest side of the red triangle, which is side E to D, has a length of 30. The middle length side of the red triangle, which would be side D to F, has a length of 22. Okay? So notice in the red triangle, I don't have any information about any one of the three angles, but I have information about all three of the sides. So that's what we mean by side, side, side. You have to have information about all three of the sides. Now, in the blue triangle, the shortest side of the blue triangle is side Q to P, and it has a length of 5. The longest side in the blue triangle is side R to P, and it has a length of 15. And the middle length side of the blue triangle, which is side R to Q, has a length of 11. Okay? So the blue triangle is my new triangle. The red triangle is my original triangle. And I want to know, are these two triangles similar? Okay, and this is going to be an example of what we call the side, side, side similar rule. Okay, so if you notice, when I write my ratios, remember, when you write ratios, it's always new triangle on the numerator, original triangle on the denominator. Here's what you notice. 5, because it's the shortest side of the blue triangle, is going to correspond with the shortest side of the red triangle. 10. So one ratio is 5 over 10. The longest side of the blue triangle, which is 15, is going to correspond with the longest side of the red triangle, which is 30. So another ratio is 15 over 30. And then a third ratio, I'm actually going to write it like this, 15 over 30. I'm going to write them going down. And then a third ratio would be the middle length side of the blue triangle, which is 11, corresponds with 22. So that ratio would be 11 over 22. And 5 over 10 reduces to 1 over 2. 15 over 30 reduces to 1 over 2. 11 over 22 reduces to 1 over 2. So all three side ratios are equal. When all three side ratios are equal, this tells us the two triangles are similar by the side, side, side rule. So we could say triangle DEF is similar with triangle, and then I'm going to finish off the sentence. So D has to match up with what letter over here? If you are yelling into your computer that it's R, you are absolutely correct. E has to match up with what letter in the blue triangle? That would be P. And then F would have to match up with Q. So triangle DEF is similar with triangle RPQ, and this would be an example of by the SSS, side, 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 similar rule. Now, what does that mean? It means that if all three sides ratios are all equal to each other, then then the side, side, side rule applies. Okay? Let's go to side, angle, side. Last one. This one is the side angle side similar rule. This is the third of 3 rules of how to prove that one triangle is similar to another triangle. So once again, let's go with a red and a blue triangle. The red triangle is going to be my original triangle. And just to mix it up, the blue triangle is going to be my new triangle, but the blue triangle is going to be an enlargement of the red triangle. Okay. The vertices of the red triangle are represented by the letters G, H, and I. The vertices of the blue triangle are represented by the letters L, M, and N. We know that angle I in the red triangle is congruent to angle N in the blue triangle. We know that in the blue triangle, the longest side of the blue triangle is 50, and that is side N to L. In the red triangle, the longest side of the red triangle is 10, and that is side H to I. In the blue triangle, side M to N is the shortest side, and it has a length of 20. And in the red triangle, the shortest side is side G to I, and it has a length of 4. Okay? So, if you notice, here's what we have in this particular problem. We have angle N is the same as angle I. We have the ratio of the blue triangle to the red triangle, new triangle to original triangle. One ratio is 20 over 4, because 20 in the blue triangle corresponds with 4 in the red triangle. I know that because they're the shorter of the two sides. And then another ratio would be 50 over 10. And I know that because 50 is the longest side of the blue triangle, and it corresponds with the longest side of the red triangle, which is 10. So we have, here's what we have. We have a pair of equal angles, that's an A. We have a side ratio, that's an S. And 20 over 4 reduces down to 5 over 1. We have another side ratio, 50 over 10, which, by the way, also reduces down to 5 over 1. So if you notice, we have a pair of equal side ratios, another pair of equal side ratios, and then we have a pair of equal angles. Okay, so this would be an example of two triangles that are similar because of the side angle side similarity rule. So we could now say that triangle GHI is similar with triangle, and then we're going to finish off the statement by matching it up. G would have to match up with M. H would have to match up with L. And I would have to match up with N. So triangle GHI is similar to triangle MLN, and this would be an example of being by the side angle side similarity rule, which says that if two triangles have a pair of equal side ratios, a pair of congruent angles, and another pair of equal congruent side ratios, and the angles in between the two sides, then those triangles are similar. Unit 2, assignment number 7's notes.